Hey guys, so welcome back. Today's video is going to be on the different types of weathering. It's part of the unit on weathering, erosion, and deposition. And weathering, erosion, deposition are an incredibly important part of the whole cycle, the rock cycle that we have been talking about. So here we are looking at page 6 of your reference table, the upper left-hand corner of your reference table. We're at the rock cycle thing we've been working on. So we talked about magma, we talk about igneous rocks, we talk about sedimentary rocks and metamorphic rocks. Okay, today and over the next couple of days, we're going to talk about some of the connecting lines that we haven't really talked about. So if you look here, you've got weathering and erosion. Once again, you've got weathering and erosion here. You've got weathering and erosion over here. If you notice, all these things are going to lead to this thing called sediments, which is eventually going to lead to sedimentary rock. So it's important that you write these words down: the weathering, the word erosion, the word sediment, and various other ones are going to pop up during the course of this video. Make sure you're writing them down. So there are two main types of weathering. The first is what we call physical weathering. And physical weathering is accomplished by some physical process. What does that mean? It means something natural: falling off a cliff, plants growing, freezing and thawing, some physical process. And that physical process causes a large rock to turn into smaller and smaller pieces of rock. These smaller and smaller pieces of rock are what we call sediment. Okay, so you take a big boulder and you break it into pebbles. You take those pebbles and you grind them into sand, stuff like that. Now, the important thing to remember with physical weathering is all you're doing is taking a big something and turning it into a small something. But the minerals and the chemical composition stays exactly the same. You're not adding anything, you're not taking anything away. So for example, if you look at the image that's in front of you, here we have some old volcanic necks in the southwestern United States. What happened to these guys is over time, wind and water and all the other things, heat, have broken these, what used to be volcanoes. As hard as it is to believe, what you're looking at here used to be volcanoes, and they've broken them down into piles of pebbles and dust and all these other things. You can actually see it down towards the lower part of the stacks in front of you. You have that hard, durable interior, but you can see the piles of debris alongside. These used to be the size of mountains, but those mountains have gotten broken down over time. The second type of weathering is known as chemical weathering. And chemical weathering involves the transformation of compounds within an object. So you're actually changing the molecules, you're adding atoms in, you're taking atoms away. You are changing the chemical properties of that. One of the best examples of that you can actually see in the picture before you right now. These are a bunch of copper pennies, and these copper pennies have oxidized. We'll talk about what that means. But if you look at the ones in the upper left-hand corner, they're bright, they're shiny, they're what you think of when you're a penny. If you look at the ones in the lower right-hand corner, you see it gets that bluish coloring, okay, that patina sort of coloring to it. Okay, this is a process of chemical weathering. These pennies have been exposed to oxygen, the oils in people's fingers, and all sorts of stuff, and it has changed the actual mineral composition, the chemical composition of the penny over time, and it'll actually start to make it break down a little bit. All right, so the first type of physical weathering that we're going to talk about is frost wedging. So frost wedging happens when you get water, rain or something like that, that enters fractures or cracks that are in a rock. Now, rocks naturally have fractures, cracks, things like that. Now, why is that important? Well, because what ends up happening is when that water enters the cracks, okay, it's going to sink to the lowest level inside the rock, wherever it can get. And at night, or if the temperature drops too much, it's going to freeze. And so what's going to end up happening is that water is going to expand out. That's what water does when it gets cold. This is why when you put something in a freezer, and you have to make sure that it's not in a glass container or it's not filled to the top, because when that water inside of it freezes, it's going to expand and it can explode. And so effectively, that's what happens here. You can see the frost wedging happening here. What frost wedging means is exactly that. As that ice gets in there, it's going to freeze and expand. It's going to wedge its way into the rock and split the rock open. And you can see that happening here, and most notably here. Okay, and so what it's going to do is going to wedge its way in there. It's going to kind of wedge its way in there, okay, and it's going to pry the rock apart. Now, this may not break the rock apart immediately at first, okay, but daytime comes, temperature goes up, all this ice up here is going to melt. It's going to sink to a lower level. Nighttime comes, or another rainstorm, water fills the holes, nighttime comes, it refreezes, and it's going to do the process again. And so slowly over time, what it's going to do is it's going to kind of wedge its way in, wedge its way out, wedge its way in, wedge its way, and slowly the rock, like this one up here, okay, is eventually going to get pushed, where this is going to wedge and wedge and wedge and crack it all the way to here, and eventually push it and push it and push it and push it over, and eventually what's going to happen? Gravity's going to win, and this rock is going to tumble down the side. As it tumbles, it's going to break. And you can actually see that here. That's what it says. So you get falling rock debris, so the rock's going to get pushed off, it's going to tumble its way down, and what you're going to get is a bunch of angular sediments. Okay, you can actually see that in the picture here, but you can see it here. What you end up getting at the bottom of this big mountain is this big pile of grayish dust and sand. That big pile of grayish dust and sand is what we call a talus slope. A talus slope is composed of angular fragments. Why angular? Well, because they fell off the top of the mountain, and they chipped and they fell, and as they broke, they got sharp, pointy, spots. Okay, and so you end up with this talus slope down here, or in real life, this thing right here. You get this at the bottom of lots of mountains, and so you get angular fragments. Well, those angular fragments can easily turn into, as time goes on and it gets buried, a sediment, okay, rich rock, so a sedimentary rock, okay, with angular sediments. What do we call angular sedimentary? An angular sedimentary rock? Breccia. So this process right here is where you're going to get breccia forming. Now, a good example of this is actually this. Okay, this was a geologic feature naturally occurring. This isn't a sculpture. Okay, this was a natural geologic feature that existed in the mountains of New Hampshire, just to the north of us here in New York. Okay, and this was called the Old Man Mountain, and it was really recognizable. It looks like an old guy, right? And it looks like a person, but they called it the Old Man Mountain. Okay, and it was so recognizable that New Hampshire put this on their license plates, and it was on a lot of the stuff that they would sell for the state and stuff like that. And people would come into the state and they would see it and they would recognize it. Lots of people took pictures. The problem was, as you can see, there are deep grooves all along this. This is New Hampshire. Okay, this is north of us here in New York. So think about, what's the weather going to be like? What are the winds going to be like? What are the, you get lots of rain, lots of sleet. It's going to seep into those holes, and you were getting lots of frost action happening in this. Now, the people realize this, but unfortunately, one day, before they could take too much action, it went from looking like this to looking like what it does on the right-hand side. And the old man on the mountain became the old pile of stuff at the bottom of the mountain. And so you ended up with a talus, slope down at the bottom of this. And unfortunately, it fell. Okay? You can no longer see this. All you will see when you drive into New Hampshire is another rock walls that's just like everything else that you've been driving through. So the second type of physical weathering is what we call sheeting or exfoliation. Okay, and so what this starts off with, it's very simple. You start off with some sort of an igneous pluton usually, so a large mass of igneous rock below the Earth's surface, okay, or some other rock below the Earth's surface that's under a whole lot of confining pressure. What that means is that you've got equal pressure on all sides, so the rock is getting smushed down. Now, slowly over time, the rock layers on top of it, or the sediment or the soil, like you see in the picture in front of you, gets taken away. Okay, the rock above it gets eroded away. At the same time, you get some sort of uplift force that pushes this pluton up. And so what ends up happening? The rock gets pushed above the Earth's surface. Now, when that happens, it no longer has that confining pressure. So what does it try to do? It tries to expand. And when it tries to expand, what's going to start to happen is that, depending on the rock that it is, okay, what can start to happen is it can start to exfoliate. It can start to sheet. What that basically means is it starts to shed and break into layers, and those layers can easily slide off. Okay, when we talk about exfoliation with like makeup or stuff like that, you're talking about removing the outer layers of dead skin. Well, it's kind of like the same thing. The rock itself will start to form joints or breaks in it. And if you look at the picture in front of you, you can actually see it looks like layer upon layer of sheeted rock on top of it. And what will sometimes happen is those sheets will break off because of frost wedging or other things, and they will just slide off. And so that's what you're seeing on the picture in front of you. This is an igneous pluton. That sheeting and exfoliation is going on. And you can actually, if you look closely, see that there is a rope trail with actual people climbing up the side of this. They're really, really small and hard to see, but you can see it. So that should give you an idea of the size of the sheets that we're talking about. So the next type of physical weathering is what we call abrasion. And abrasion is typically caused by either wind or water moving over a pre-existing rock. Now, how does this happen? Well, when we look at wind and water is always going to have little bits of other sediments, little pieces of particulate, sand, and things like that. And as that water or that wind travels along a surface, what it's going to do is it's slowly going to wear it down through friction. It's slowly going to wear it down. And when it comes to a rock, what it's going to do is it's going to start to round it out. It's going to start to take away the sharp, pointy places and start to leave rounded edges. And so as the wind blows or as the water flows along the surface or bottom of a river or something like that, it's going to tend to round out the rocks that are in that location. Okay, and so what you're going to end up with is, instead of these sharp, jagged rocks, you're going to end up with much more of a smooth, or a rounded, I shouldn't say smooth, a rounded appearance. Now, how do we tell the difference between wind abrasion and water abrasion? Well, if you look at the picture in front of you right now, you can see there's a difference. Water abrasion is typically going to cause your rocks to get that smooth appearance. They're going to be round and they're going to be smooth as the water flowed over them, took off those edges, and it smoothed them out. It's going to create what we call river rock. People like to use this for decorative purposes in driveways or inside their houses or things like that. It's very smooth, it's very soft. If you ever pick up a rock and it's round and it's smooth, chances are that rock was inside a river at some point. Wind is still going to round the rock out, but what it's going to do is it's going to tend to put lots of little tiny holes, because effectively what wind abrasion is it's like sand blasting. So imagine, if you've ever been outside and the wind kicks up and the little bits of sand hit you in the face, imagine that happening over and over and over again. Now, whereas it will round things out like you see in the picture, if we were to zoom in, what you'd actually notice is that that rock actually has tiny little pits, little holes in it. So that's one of the ways that we can tell if something was abraded by water or if something was abraded by wind. The last type of physical weathering that we're going to talk about is biological activity. And this is exactly what it sounds like. This is weathering caused by the actions of living things. The most common example of this is what you see in front of you right now, which is what we call root action. And what root action basically means is that you had a plant and the seeds of that plant landed in some dirt that was maybe in a crack inside of a rock. And those seeds germinated, they grew, they sprouted, and as they did, their roots spread out, and so did the other parts of them. And as they spread out, they slowly wedge the rock apart. This is very similar to the frost wedging. The bigger they get, the more they're going to split the rock apart. As you can see in the picture, the roots in this are doing a really, really good job of breaking that rock apart. Eventually, the roots are going to be able to break that rock and it will fall down and it'll break and turn into angular fragments, talus, and all the other things. Okay? Plants do this all the time. You know this in your backyard or in your driveway or things like that. That's why you always got to pull the weeds, because slowly over time, those roots growing out can break up just about anything. It's just a matter of time. The other example I'm going to give you is us. What you're looking at right now is a mine. Well, think about that. That used to be solid rock, and humans dug all that rock out and moved it. That would be weathering. Humans do this all the time. Anytime we build a tunnel, anytime we build a building, anytime we take granite out for countertops, we are doing weathering. Okay, human activity. Other animals do it as well when they dig burrows or homes or things like that, but humans are probably the biggest example of it happening now on the surface of the earth. The first type of chemical weathering that we're going to talk about is oxidation. So what happens in oxidation is you're going to change the chemical structure of the rock by adding in oxygen. When you add in oxygen, effectively what you're going to do is rust the rock. Okay, so if you're looking at the picture in front of you right now, you can actually see you've got a sample of granite that has two different shades to it. The inner granite is the typical what we would think of as granite, but you see how the outside has that brownish reddish color. Why? Because that outside portion got oxidized. The chemicals, the molecules in that outer layer were exposed to the air, they combined with the oxygen, and they changed. And now the outside portion has different properties, physical properties and chemical properties, than the inner portion. Like I said, oxidation is usually what we refer to as rusting. So if you're looking at the picture now, I know it's a little disturbing, but this is a steel slab that has oxidized. It has started to rust. And so what has it done? You see how it's got those reddish splotches. Those are little chunks of rust. Now you guys all know rust versus actual iron and steel. Rust is much more easily breakable. It flakes and stuff like that. And so chemical weathering can actually improve or increase the amount of physical weathering. And so they work together. Okay, the next type of chemical weathering is what we call dissolution. So in dissolution, what happens is if you have ionic bonds in your substance, those bonds get broken. And when they get broken, different ions can get carried away. So for example, if you had something like sodium chloride, you'd break the bond and the sodium might get carried away and the chlorine might get carried away. Now, sometimes those ions can precipitate. Remember, we talked about this before. If there's too many of them in water, they'll come out. Okay? Or if the water evaporates, they'll come out. This is how we get stuff like halite and gypsum. Okay, now sometimes when those ions are in the water, they can actually form a very weak acid. And when they form that very weak acid, for example, you see the compound at the end, that's what we call carbonic acid. I'll repeat it again, carbonic acid. Okay, those weak acids in the water can actually start to eat through minerals that react with acid. What mineral reacts with acid? We talked about this. Something like calcite. And so what ends up happening is if you have a rock that's made out of limestone, like the picture in front of you, it'll start to get these little holes. And given enough time, what you'll actually end up with is something that looks like